here is the example of ideal inverting op-amp or amplifier. For what range of input does the op-amp in this example stay linear? And the second question is calculate the value of VO and V at inverting terminal, Vn, for the cases of Vs 0.4, minus 0.6, 3.5, and minus 2.4. For first question, we know it's ideal op-amp, and therefore we have infinite input impedance, so no current is going to negative, no current is going to positive terminals. Plus, because it's an ideal op-amp, it will force virtual short between the positive and negative terminal. So Vn should be equal to Vp, or V of positive terminal, should be equal to ground or 0. From these, we can write KCL in the form of all the current flowing out of the op-amp will pass through the feedback resistor 80 kilo ohm back to the source resistor 16 kilo ohm and back to the source. So from KCL we can say VO minus Vn divided by 80 kilo ohm should be equal to, since no current is flowing to the op-amp or coming out of op-amp in input terminal, we should have Vn minus Vs divided by 16 kilo ohm. Now, as far as op-amp remains in linear region of operation, then the conditions here will hold, and by linear region it means V out should not go above plus 10 volt, should not go below minus 15 volt. So as far as this is true, then these conditions are true, and we can say Vn is 0, so we get the result of VO over Vs should be equal to minus 80k divided by 16k, which is gain of which means a gain of minus 5. And from there we can find out what is the range of input assuming that op-amp stays linear. So if op-amp stays linear, it means VO should be less than or equal plus 10 volt and should be more than or equal minus 15 volt. Given that the gain is minus 5, given the gain, assuming op-amp in linear region, we can say Vs should be less than or equal, in case of minus 15 divided by minus 5 we get plus 3 volt, and in case of plus 10 volt divided by minus 5 we get minus 2 volt. So this is the range, acceptable range for Vs, so that op-amps remain in linear region of operation. That's part 1. 2. When Vs is 0.4, because it is in this range, we know op-amp is in linear region. Therefore, we can simply say V out is gain times Vs, which means minus 5 times 0.4, it is minus 2 volt. When Vs is minus 0.6, same thing, it is still in this range, so we can say op-amp is a linear mode of operation, so V out is again gain times Vs, that is the closed loop gain that we found, so this is closed loop gain, so it is minus 5 times minus 0.6, we get positive 3 volt. Now when Vs is 3.5, Now it is beyond the range that is acceptable for input if we want the op-amp to stay in linear region of operation. So we see that op-amp will be saturated if op-amp could stay in linear region. Then because the gain would have been -5, then the output would be -5 this guy times this guy, which means output would be minus 17.5 volt, which is less than this. So we get to the point that V out will be minus 15 volt and op-amp saturated. In this case, op-amp was not saturated, so we could have said these conditions are valid. So it means Vn remains equal to Vp, and since Vp is ground, Vn also remains equal to 0 or ground. But here, op-amp is saturated, so we have to go back to KCL, and we have to say minus 15, which is V out, minus Vn, which we don't know, divided by 80k is equal to Vn, we don't know the value, minus Vs, Vs in this case is 3.5, divided by 16k, and this is 5 times. So from here we get to the point that minus 15 minus Vn equal to 5 Vn minus 17.5. So we can say 6 Vn is equal to 2.5. So we can say Vn is 2.5 divided by 6 volts. Finally, for the case of Vs equal to minus 2.4, we can see that it's less than the acceptable value for the op-amp to remain in linear region. So we get to the point that op-amp is saturated again in this case. So if op-amp could stay in linear region, then we would have said Vs minus 2.4 times the closed loop gain minus 5, we would get 12 volt, but that is above acceptable VCC or voltage plus 10, so we can say V out because of saturation becomes limited to plus 10 volt supply. And again we write the same thing as we did here, so we would say using KCL, V out, which is plus 10 volt, minus Vn, which we have to find, divided by 80k equal to Vn minus Vs, which is minus 2.4 volt over 16k. So same thing as before. We can say that 6 Vn is equal to this guy is plus 12, so become minus 12 plus 10 minus 2, so we can say Vn is minus 1 over 3 volt.